Hello, sir. Can we start? Hello, sir.
Hello.
Okay, so good morning, everyone. I'm Niharika Parab. We are giving a presentation on a course that we have done called as a Networking Essentials from Cisco Networking Academy. The group members are Tushar Yadav, Niharika Parab, Rutuja Guge, Pratik Darade, and Saurav Mohile. The following content will be internet connection, network protocols and architecture, data communication and network services, home network basics, and introduction to the Cisco networking. I now request Rutuja to take it forward.
So the first topic is internet connection. The internet is a worldwide collection of interconnected networks cooperating with each other to exchange information. It is considered as network of networks because it is literally made up of thousands of local networks that are connected to each other. Depending upon the sizes of networks, there are four type of networks. The first one is small home network. It connects a few computers to each other and to the internet. Second is small office and home office networks. These networks allows computers in home office or a remote office to connect to a corporate network or access shared resources. Third is medium to large networks. These networks are used by corporations and schools. And the last one is worldwide network, which is a network of networks that connects hundreds of millions of computers worldwide. So when we stream a movie or play a multiplayer game, we require reliable and fast connections. To support these high bandwidth applications, networks have to be capable of transmitting and receiving bits at a higher rate. The rate of data transfer is usually discussed in terms of bandwidth and throughput. Servers and clients. In modern networks, computers host can act as a client, a server, or both. Servers are hosts that have software installed which enable them to provide information like email to other hosts on network. And clients are computer hosts that have software installed that enables the host to request the information obtained from server. Niharika. Network infrastructure contains three categories of hardware components. First one is end devices. The network devices that people are most familiar with are called as end devices. For example, computer network, printer, security cameras, etc. Some examples of intermediate devices are wireless router, LAN switch, firewall appliances, and examples of network media are LAN media, WAN media, etc. There are two types of topologies, and examples of physical topology and logical topologies are given as shown. Next one.
Hello, I'm Saurav. We'll be talking about network protocols and architecture. So, protocols are a set of rules and standards followed by computers to communicate with each other. Some examples are file transfer protocol, HTTP protocol, SMTP, email protocols. And these are network models, TCP, IP, and OSI models. They show us how networking and communication takes place layer by layer. So in the OSI model, the physical layer is the lowest layer. This layer deals with physical components such as hubs, cables, routers, etc. Then there is the data link layer. Here the data is packaged into frames, and node-to-node transfer takes place. In the network layer, the layer takes the frames from the data and transfers it to the relevant destinations using IP addresses. In transport layers, This manages the delivery between the network and checks for errors. In the session layer, it controls the conversation between different layers. And in the presentation layer, the data is taken from layer and it is translated for the application layer. Application layer is where the hosts and the servers access the networks. In hierarchical network design, the network is divided into 3 core layers, which are core layer, access layer, and transport layer. In the access layer, the hubs and the hosts and the servers access the network. In the distribution layer, the transport takes place. And in the core layer, it provides fast connections for the hubs. Next, local area network is it is not very costly to set up. It is easy to set up. And it has a few disadvantages like security risks. Like it is easy to break into a local area network, and if one host is affected by a virus, it will affect the whole local area network. And if the server goes down, then the whole network will go down.
Okay, hello everyone. So I'm Niharika and I'll be talking about the data communications and network services. So one of the examples of the network services is the IPv4. So in that the IP stands for the Internet Protocol and the V4 stands for version 4. Along with IPv4, we also have IPv6, that is the Internet Protocol version 6. The difference between these two are the IPv6 is a more advanced version of IPv4 and it has greater speed. So I'll talk a little about IPv4. Now, the IPv4 addresses can be assigned either statically or dynamically. So statically is basically they are assigned by the ISP, that is the Internet Service Providers, and they are a permanent address. So that is the address, the Internet address, the ISP, they cannot be changed. So, and the IPv4 dynamic, that is the dynamically. So in that these addresses are subject to change. They are assigned by the dynamic host configuration protocol, that is the DHCP servers. And basically these dynamic IPv4 addresses cannot be changed. So you might ask why we use dynamic IPv4 or why we use static IPv4. So basically the difference is in static they do not provide a lot of IP addresses, like they don't have enough to provide for everyone. So basically that's why we use dynamic IPv4. They have enough of these IP addresses to go around. So I'll give you all an example. Basically consider a hotel. A hotel as a whole will have a static IPv4, but the rooms, as we all know, hotels have multiple rooms, lodging rooms. So those rooms will have the dynamic IPv4 addresses. So again, each host of the IPv4 addresses of the router interface is also known as the default gateway address. Now coming to the client and the server interaction. Now we use internet and its services on a daily basis, but we rarely think of the servers, the clients, and the networking devices that actually take place to make these actions happen. So what basically the client and server interaction is, I can of a web server. So web server, for example, it can be Google Chrome or Mozilla Firefox, where on a single application we can check our emails, we can listen to songs, we can write messages, surf the net, surf various social media, etc. So all of this can be done on just one application. So that is the client and the server interaction. So all of this is called as a server farm. So from client to the server, the internet helps us to do all of these actions. And lastly, I'll talk about the common network and application services from my side. So one of the first application is domain name system, that is the DNS. So it resolves internet names to the IP addresses. Then we have the SSH, that is the secure shell. It provides remote access to servers and networking devices. Then we also have email servers. which sends mails from client to server and server to email servers. Then we have the DHCP, that is the Dynamic Host Configuration Protocol. As I said, they help in automatically configuring devices and IP address. So, and next we have the web server, that is the www, that is World Wide Web. It requests web pages to web servers to transfer files. And lastly, the file transfer protocol, that is, it is used for interactive file transfer between systems.
So I'll be briefing you about the home network basics and the network technologies at home. First is the electromagnetic spectrum. Wireless technologies use electromagnetic waves to carry information between devices. The electromagnetic spectrum consists of waves such as radio waves, gamma rays, X-rays, visible light, etc. These are really important for carrying out data. There are some parts of the spectrum that are regulated by the government for only organizational use for only for specific applications, while there are certain waves that are made public in order for public usage without the need of any kind of permit. Wired network technologies, there are different types of wiring media used in order to connect devices. First is the category 5E cable. These are 4 wires that are twisted and turned to form an entire cable. These twists are done in order to prevent any kind of interference between the cables. The difference between category 5 and 5E cables are that 5E cables are superior. They have faster data transmission and are more reliable. Coaxial cable consists of central conductors which are centrically surrounded by a conducting material. Both these substances are separated by a dielectric medium. ISP Connections, an internet service provider, provides the link between the home network and the internet. It can be a local, an ISP can be a local cable provider, telephone service provider, etc. They are critical to communication across the global internet. Each ISP connects to other ISPs to form a network of links that interconnect users all over the world. ISPs are connected in a hierarchical manner, which means that there are 3 tiers: Tier 1, Tier 2, and Tier 3. The Tier 1 ISPs do not pay any kind of traffic cost. For example, AT&T. Tier 2s connect the Tier 1 and Tier 3s. They have to pay traffic cost. For example, our local cellular network providers such as Vodafone, and Tier 3 are the ones that connect the end users to the internet for that are local cable providers. Most home and small networks usually do not require more than 1 or 2 networking devices in order to function efficiently. But for a large organization such as a college, internet is needed to be provided to a large number of people. This is where switches and routers come into need. As switches and routers have evolved, the distinction between them has diminished, although one simple distinction remains. LAN switches provide connectivity within the local area network of the organization, while routers interconnect common local networks and are needed for the wide area environment. Troubleshooting. Troubleshooting is the process of identifying, locating, and correcting problems. There are several structured troubleshooting approaches that can be used. Few of them are noted below. Top down. As we have seen, there are 5 network layers: application, transport, network, data link, and physical. So top-down method is used when the problem is thought to be software oriented. In this, the network administrator starts his work from application layer of the network and works his way down. On the other end of the top-down network, we have bottom-up network. In this, the problem is thought to be hardware or cable oriented, and hence it starts at the physical layer of the structure. The divide and conquer. In this, by collecting user experiences, symptoms, and network administrator makes an informed guess and then decides which layer to work on. If the said layer is working properly, then he proceeds to move up or down as per needed. Software utility programs available that can help us identify network problems. Most of these are provided by operating system as a command line interface commands. Few of them are noted below. ipconfig. It helps us display the IP configuration information. Ping tests the connection to other IP hosts. Netstat. It displays network communication. TraceRT displays the route taken by the packets. And NSLOOKUP. It directly queries the name server for the information on the destination domain. With this, we are done with the PPT on network essentials. Thank you and have a nice day.